Portable DIY Electronics Workstation. This is a portable multi-purpose device designed for various electronics applications. It combines versatility, portability, and functionality, making it ideal for both beginners and professionals. With its compact design and multiple features, it serves as a reliable tool for different projects and experiments. Supplies: Raspberry Pi 4B D-Frobot, 7 inches HDMI display with capacitive touch D-Frobot, DC-DC buck converter D-Frobot, Raspberry Pi 4B GPIO terminal block, hat D-Frobot, spacer kit D-Frobot, PCB NEXT PCB, COM. 18650 battery holder -3 nose. 3S 18651 OABMS. 5mm LED, 9V buzzer, 1K resistor, on OFF switch -3 nose. XL4015 module. USB socket 2 numbers. DC volt amp meter. 18650 battery indicator module. Acrylic laser cut, 12 volt socket, USB-A to Type-C cable. HDMI-F to micro HDMI converter. Micro B USB cable. Step 1. Designing and ordering a custom PCB. For this project, I designed a custom PCB, using EasyEDA, a user-friendly online PCB design tool. EasyEDA allows for schematic capture, PCB layout, and even simulation. Once the PCB design was finalized, I placed an order with Next PCB, a reliable PCB manufacturer that provides high-quality fabrication services. They offer quick turnaround times and precise manufacturing, ensuring that the PCB meets the required specifications. Steps to design and order. 1. Open EasyEDA and create a new project. 2. Design the schematic for the circuit. 3. Convert the schematic to a PCB layout and arrange the components. 4. Route the PCB traces and set design rules. 5. Generate Gerber files, which are required for manufacturing. 6. Upload the Gerber files to Next PCB and place the order. Step 2. Soldering the components. Once the custom PCB arrives, the next step is to solder the necessary components onto it. This project involves creating a continuity tester, so we will be soldering the following components. Required components: buzzer to indicate continuity, LED for visual indication, 1K resistor current limiting for the LED. Soldering steps: 1. Prepare the PCB, ensure the PCB is clean and free of dust. 2. Place the components, insert the buzzer, LED, and 1K resistor into their designated positions on the PCB. 3. Solder the components, heat the pad and component lead with a soldering iron. Apply a small amount of solder to create a strong connection. 4. Trim excess leads. Use wire cutters to trim any excess component legs. 5. Inspect solder joints. Ensure there are no cold solder joints or bridges between connections. Once all components are soldered, the board is ready for testing. In the next step, we will verify the circuit functionality. Step 3. Using XL4015 module and DC voltage and amp meter. In this step, we integrate the XL4015 buck converter module and a digital DC voltage and amp meter to make the device multipurpose. The XL4015 module allows voltage adjustment using a potentiometer, while the VA meter displays real-time voltage and current readings. Components used: XL4015 step-down buck converter module, adjustable voltage regulator. DC voltage and amp meter module, digital display for voltage and current. Steps to connect. 1. Open the VA meter case. Carefully remove the plastic casing of the digital voltage and amp meter to expose the circuit board. This allows for direct PCB mounting inside the custom-built device. 2. Mount the XL4015 module. Place the XL4015 module onto the PCB. Secure connections for input power, VIN, and output, VOUT. 3. Fix the VA meter PCB. Secure the exposed VA meter PCB onto the custom PCB. Ensure it is properly aligned for visibility and stability. 4. Wire the DC VA meter module. Connect the input power of the VA meter to the output of the XL4015. Attach the current sensor in series with the output load to measure amps. 5. Adjust the output voltage. Turn the potentiometer on the XL4015 to vary the voltage. Observe changes on the digital VA meter display in real time. 6. Verify functionality. Ensure the voltage adjusts smoothly. Confirm the amp meter reads current properly.